Okay, hello everybody, and welcome to another tutorial of robotics. In this case, we are going to talk a little bit about programming. Programming is one of the most important parts in any robotic system. It's the way to tell the robot what to do and to apply and specify a set of routines that the robotic system has to develop. There are many ways to create programs that have different tasks for robots. Remember that we are working with the microchip um, MCUs, and those can be programmed in many different languages. The main language for microchip is assembler. It uses zeros and ones. So developing any task will be very difficult and very challenging because you have to develop many lines of code in order to blink a LED, to turn on a light bulb, or to run an engine. Now there are many compilers, and this is what we're going to talk about now. This one that you see over here, this is a compiler that interprets and translates C language, that is one of the most common languages in the world, and translates C to the assembler language that the microchip uses. Okay? Now MCUs will change all that C language programming into the binary system, and it will be translated into zeros and ones, something that the MCU will understand. So basically what we have here is just the environment of the software that I'm using. In this case it's called Picc. And what I'm going to do is that I'm going to start a project. And I'm going to start with a wizard. Okay? Now this wizard is going to ask where to save the project. So I'm going to save it in my documents, and I'm going to call it motor drive. Okay, because I'm going to drive two motors in this case. Okay, and here I have a little wizard. Now this wizard is going to allow me to choose the MCU that I need. Okay, now I'm going to choose the MCU, the device. So the device is the 16F887. This is the one that we're using. Remember that we talked about the frequency. Okay, that's the speed where the MCU develops certain tasks. So I'm going to use 4 megahertz, 4 times 10 to the power of 6. So that would be 4 megahertz. Okay. Now I have a set of options here. I'm going to leave them just like that. And here I'm going to choose the type of oscillator that I'm going to use. Remember that you can use external oscillators or internal oscillators. This MCU has a built-in oscillator. Okay. I'm going to use internal RC oscillator with no clock out. Okay, I'm not going to use the pin for clock out because I'm going to try to use all my pins for digital inputs and outputs. Okay, that is going to be very simple, and I can activate the master clear pin. Okay, in order for it to work, remember that pin number 1 from this MCU has to be connected to 5 volts. Okay. I'm going to leave this exactly the same, and I have a tab that says code. This code is going to be embedded into an H file, which the compiler is going to use, and it's just a configuration of the MCU. It says that it's a device and that it has no fuses, that it has no watchdog timer. This is a configuration that if you want to study how it works, like every single configuration, it's really helpful if you're going to develop more complex projects. Okay, now I am going to click on OK, and I will have my software. So it says include motor drive .h. So in this document you're going to have the configuration of your MCU. I prefer, and this is what I'm going to do, I have it already done, so I'm going to just paste a little bit of software that I did, and I'm going to explain it step by step. Okay. Now this is the environment, and these are the lines of code. Okay. Now the header of the program would be all this. If we're going to use the same MCU, the 16F887, we're probably going to use this header all the time with some changes sometimes. But basically, we need to include, this has to be always, include this MCU, has to be exactly. When you're program, you have to write it exactly how it is, how the compiler will understand it, okay? So there are some functions that you have to learn by memory. You have to write them exactly how they are, either in capital case or lower case, because it's case sensitive. Now we have the number include, this is a function, so we're including this MCU. And we're saying that this device, it's 16 bits, okay? Now, Microchip has different types of generations and different types of MCUs. Some of them are 8, 16 bits, 32 bits, and 24 bits, and they grow larger in size, in memory, okay, and capabilities and functions, okay. So this Picc is 16 generation, 16 bits, and we have here the normal configuration that we use on the wizard, so you can always put that here. Remember that if you're doing it this way, you shouldn't have the H file that was generated by the wizard. Okay, you can just write it like this, and it has the configuration right there on the program. Okay, we have number use delay. Now this is another function that you have to memorize in order to establish the frequency which the MCU is going to work. In this case, it's an integer variable of 4 megahertz. Okay, so we have a delay, or the frequency that the MCU is going to use, and it's 4 megahertz. Now here's another function. Number use fast IO B, and in other words, because this is not something that we're going to study in depth, but you use this in order to change the either input or output for the B port. So this function is saying, look, on the B port, all those pins, I want to use them either inputs or outputs anytime I want. So make that change whenever I need it. Okay, so I don't have to configure the input and output permanently. Okay, they can do a fast input and output. And this one, I also use it because sometimes I want to use the whole port. I want to either turn on all the 8 bits of the port or just turn off all the 8 bits of that port. So I name the port B in order for me to develop it on the program and not call it just pin by pin. In other words, this is the header that we probably are going to use all the time, sometimes including other ports, okay, and the port address is going to change a little, okay. This number 6, it's the address where that port is going to be located, and I can call it from there. I can use it from that address. Now, when you see void main, we're talking about the main program. We're talking about a program that does not return any value because it's void, and main means that it's our main program. Okay, that is our main program. Sometimes we're going to have sub-programs, and they need to be called from the main. Okay, now always a main program needs to open these keys, okay, in order to work. And here I have a very important function that you guys will basically need all the time, because what we're doing in this part of our course is that for an input, we are going to have an output. Okay, so we always have to use, and we're going to use this function called a conditional function. And the conditional function is going to ask the MCU for the state of a pin. What is the state of a pin? Either 0 or 1, depending if it's on or off. Okay? Very good. Now, I am saying here that if the input, and it's very simple, it's a very organized programming language. If the input on the pin B0, now remember that B0 is a pin on your MCU, on that port, or sometimes you find it on the data sheet as RB0. Okay, so where you see RB0, if there's an input on the pin B0 equal to 1, saying that it's equal to 1, okay, it's not, I'm not assigning this number, I'm comparing it. And when I'm saying that it's equal to 1, is that, is there current there? Okay, is there current flowing? Is there an entrance? So I'm asking, is there an entrance or is there current in this pin? Now, if that is true, then he's going to execute this set of commands. Now, that is very important. That is what the if statement tells you. Now, you can change the pins. Pin B0, pin B1, pin B2, pin B3, or on different ports, like pin A0 or A1 or A2. Okay? Now, here's another command, output. Output, underline low, means send a 0 or don't send any voltage through that pin. Now look what I'm saying, and this is what I said that I use port B all the time, that it would be easier. Now I say output low, port B, is that all my port is going to be on zeros before I start to work the program. So first, if there's any current on those pins, then just put 0 on each pin. Okay, I'm saying output low, and on all the ports. Then I want to start driving my motor. So basically this program, and you probably notice where it leads. If I press a button, okay, on the B pin, on B0, okay, if I press a button on B0, then these pins are going to turn on. Okay? Now, output high on B4 and output low on B5. So I'm going to get a 1 and a 0 on B4 and on B5. Now, this would be one motor. Now, if I want to move or drive two motors, then I would use output high B6 and output low B7. After this, I can tell the program just to do it for a period of time, just delay on milliseconds, and I'm going to do it for 2 seconds. Okay? Now I have to put 2000 because it's in milliseconds. Okay? So he's going to do this for 2 seconds, and then I'm going to turn off the motors again. So easily I can just write output low port B again, and the motors will shut down. Okay, I close the condition. That's very important. Now I close this condition, and then I go out of this condition, and then I go out of the program. So this is what he's going to do. But I need this program to repeat itself all the time. So there's another command, very important, that it's while. And while true, while the program exists, I am going to continue asking for B0. So what I did here is while true. Now, always keep on this loop. Okay? So he's going to continue on this loop all the time. While true, he's going to ask for B0. Okay, so this is the first tutorial for electronics and robotics and programming in C language. It's very important that you remember by heart the header of the program and, of course, the void main, how to create this. Programmers eventually need to learn the basic commands in order to program efficiently. So it's good that you remember void main, the while command in order to do something forever, okay, a loop forever, and inside those commands, inside those loops, if the if conditional, if something happens, then do this. Remember to close your conditionals, and at the end, close your void main. After you finish this, you can compile it. Now, when you compile a software, you're probably going to get some errors, but that is okay. We will learn that on our other tutorial. Okay, so here it's compiling, and there's 0 errors and 1 warning. If there are no errors, you are done. And